It's awesome to be here. I mean, this is my second time in Russia in a year, so awesome. Welcome to this talk. So for starters, who am I? My name is Srdjan Vranac. I am from Serbia, from city of Novi Sad. I run a company called Code for Hire. It is a small consultancy of heavy hitters. Some people call me architecture or software consultant. Some people who work with me on projects actually call me the darkness, but that's a different thing. And I make developers uncomfortable and engineers very happy. I'm also a father of two beautiful girls. This microphone is so... Okay. Father of two beautiful girls. One is 9 and the other one is almost 4 months old. If I'm not working or spending time with my family, I'm getting lost somewhere on a trail in search of a new adventure. So, a word of warning before we begin. I'm partial to using images, as I believe that they drive the message better into your brain. And I also don't have a lot of code on my slides, so sorry about that. And as we are talking about distributed systems, the speaker may or may not exhibit race conditions with words, lagging thoughts, or occasional seg fault or ORM. This is not a result of poor preparedness. This is a carefully choreographed act that you should not try at home. So, welcome to the DDD talk. No, not that kind of talk. Today we're talking about distributed domain destruction, right? So for starters, we need to define what is a distributed system. The simple definition is that it is a system where you can distribute processing tasks to other workers, right? Those are costly tasks usually. By costly tasks, I mean anything ranging from heavy computation and CPU utilization to long-running processes. If you're talking in the context of web applications, anything that cannot be done within a span of a web request is a good candidate for distribution and background processing. Or if we're going to talk about a more realistic definition by Leslie B. Lamport, which is basically granddaddy of distributed systems, a distributed system is one in which a failure of a computer you didn't know even existed basically renders your own computer unusable, right? So, crash course. Imagine you wrote a shiny new web application that scrapes information from different websites about some products every 12 hours, right? So far, so good. It's a simple setup. You have a HTML for a URL. You look for a few things in it. You update the database, create a screenshot for auditing purposes, and move along. It works really well, right? And now, as the number of products grows, your current setup becomes insufficient and underperformed for your needs, right? So now you need to switch to distributed systems by using task or message queues. The distinctions and ins and outs between the message queues and tasks is like a whole different talk, but for now, we are going to talk about what is needed for you to set up your distributed system. In essence, you're going to take an axe to your code, and you're going to split things up. Because now you're going to have a set of workers that are going to get the HTML, you're going to have another set of workers that are going to parse the HTML, another set of workers to create the screenshot from the URL, and then you add some publishing scripts, and the publishing scripts basically are the ones that start the whole thing, and a message broker like RabbitMQ. And this is great because now when you split things up, you can scale as much as your client wallet allows, or heaven forbid, your own. Congratulations, you are now distributed. So, now that you can scale, you can go and talk to your clients, right? And lay out the plan, right? It's really nice and simple. You want some 1,000 workers or so spread across 20 instances, because then you can have like 50 workers per instance, which is really good. You can get cheaper machines and bring the cost down, and tie it all with a message broker, and you lay it on, and you lay it on, and you lay it on, and then you see it. You see that moment when you just lost them. And then the next part of the conversation goes something like, so, you know, why don't we just get bigger instances? So, like 500 workers per instance, that means we have less hassle, and this might be cheaper as we have less overhead. And there goes your plan. You're trying to hold back your tongue, not to say what you actually mean, but you know, you still get to launch your system and see where it goes from there. So In order for your distributed system to work, you need to keep your workers running, as they are going to exit because of a timeout, no jobs available, some exception, whatever, right? And you are going to be using daemons to keep an eye on them and start them up in the number of instances that you need. So these are like the most popular ones. You have the supervisor, upstart, and systemd. Supervisor is basically the oldest one, I think. It's basically granddaddy of them all. It is Python, all batteries included, everything works rather nicely until you have like 350 workers running, and then some weird things start happening. Basically, you are going to have a stampede, and supervisor is actually going to try and restart your workers constantly until it crashes and brings your whole system down. Or we're going to talk about upstart, which I think now is a dead project. That was Ubuntu's, Canonical's take on supervisor, and they were using a concept of stanzas, which is a fancy name for a template, and they had this concept of signals, so you can actually fine-grain your controls and your workers could react better until you try to use more than like 3 signals. Then upstart would start breaking down and missing the signals, and you have a situation when you want to stop your workers, upstart messes it up, and you have a whole bunch of zombie workers running, killing your machine. As far as systemd goes, I'm told it is a tragedy unto its own, so no need to repeat it. And sooner or later, you will be looking like this when you're working with daemons. It's unfortunately unavoidable, right? So on to something more serious, logging. In a normal application, it is nice to have, right? In a distributed system, this is essential, right? Because that is the only way you're going to find out what is going on in your system, and if you're lucky, maybe it will show you how it broke. And when I say log, I mean log and count. Not only outputting the information from your application to the files and basically counting everything and graphing it up. And then you can see how many counters at any given time you have. And if you see any of the counters going down, you know you have a problem, and you can take steps to basically improve upon that, right? And when you aggregate all this data and put it in one place, suddenly you can see how your every action of your system, and you know what is happening, right? So when you run something locally, it might take 5 or 10 seconds, but you have no actual idea what it means, right? You have no context. But when you run it in production, now it makes sense, because there is a lot of external factors that are going on and that are going to have an effect on that timing, and you're going to have an idea what is going on. So you need to know how long does an execution take, how big is the queue, whatever, right? The more metrics you collect, the fuller picture you have of your system. And a lot of those measurements include collecting data from from different things like memory usage, I/O use, CPU rates, message broker, supervisor, daemons, whatever. Eventually, as I said, once you measure the application, you know what is happening. So one of the best tools out there is StatsD from Etsy. It is a daemon running on your server, and it allows you to send its measurements. It's going to collect them and store them on a server so you can actually graph them later. But here's the sad fact. Logs are lying to you. I mean, or at least they will try to. They don't do it on purpose. It's just sometimes you'll encounter a piece of code that looks good. Even upon detailed inspection, it really looks good. And then you unleash it into production and all hell breaks loose. So, one application that we developed was using DynamoDB as one of the backends for data store. Yeah, multiple backends, but this is a whole different story. So, a crash course. What is DynamoDB? Does anybody know? Oh, cool. I'm going to see if you're going to disagree with me. So, DynamoDB is Amazon's take on document or NoSQL database. It is built with speed and scale in mind. And by setting the proper throughput on reads and writes, you're being charged money. Basically, the more speed you need, the more money you spend, right? And after using a couple of years of it, I believe it is a prime example of everything that is wrong with NoSQL databases, right? So, back to the story. The application is storing data in the DynamoDB. It processes about 4 million items, multiple times per day. So if you do the math, it is possible that you have 10 million records daily that needs to be ingested by database, right? The data is stored in temporal tables. That means that every day there is a different table for the data to be inserted, again by Amazon's best practices. Getting the data out of those tables is a separate world of pain. The logging and metrics are there. They're following the ingestion. Everything is as it should be. We have exception handlers in place, and everything looks good, right? The data is being written in batches, as it is the optimal way to do, again, per Amazon's best practices. The new deploy is running as smooth as you can imagine. Everything looks perfect, right? Everything is green. All the counters are working. You're just happy. And then you get a Slack message. Are we writing data to DynamoDB? And that's when the fun begins. I'm looking at the DynamoDB console, and I see, like, checking the tables, and I see that data is missing. And not a bit of data, but a lot of data. Over the course of a week, 40 million records have been lost. Nobody knows how, right? The logs are green. The metrics are green. What happened? Like, number of hours of head-scratching passes. I know that something is broken. I have no idea what it is. I'm running workers manually to see if I can reproduce. Nothing. Then I start wondering why there weren't any exceptions at all. Like, I like to think that I'm good, but I know that I'm not that good, right? And that leads me to documentation, and that leads me to the biggest WTF moment so far. This is a screenshot of the official Amazon documentation for a DynamoDB client constructor, right? Apparently, in Amazon, nobody knows how to use bold. Who here can say that they read more than 3 lines? Raise your hand. I'm so glad that you're honest. So if you go here, AutoFlash batch writer, error. Yeah, good luck finding that. So apparently you can pass a callable that is going to get called in a case of an error, and that is when the exception will happen. So let me say this again, what is happening. By default and by design, when the error happens, the batch writer will ignore it, drop the payload, and continue on, giving you a false positive, which in turn will lead to 4 days of data being lost. Yeah. On the other hand, now that I know what I need, I can register actually a callable, and I will get an exception as an argument, which does not tell me much, because by the time I get the exception, the payload has already been lost, so I'm left there twiddling my thumbs and thinking happy, happy thoughts. Right. So, okay, fine. At least I have something. Now I'm having exceptions. I can actually see what the hell is going on. And I'm starting to lose my mind. There are 2 types of exceptions. 60% of them boil down to one thing, and that is typecasting. DynamoDB needs to have its data typed, right? And it only has primitive types like numbers, string, or text, or something like that, because why would you use native type system? Who cares, right? And ultimately, the payload is JSON, right? And if you do not encase your data, or your numeric values, Java will try to infer the type from the values passed, because DynamoDB is a Java application. And then DynamoDB will not recognize those types, and is going to have a PC fit, which leads to 40 million records being lost. Fun. The other 40% was basically you cannot mix multiple types on a string. So at that point, I had enough. The error rate was too much. I just stopped the workers. I rewrote that portion of the application to use MySQL, started the workers again. We processed the whole batch. In about a day or so, we caught up, and everything was good, and we never looked back. So that system has been launched then. The performance was there. We were not losing data, which is awesome. Everything is running smoothly, and then weird things start to happen. The system slows down. and then go back to full strength. And it goes down, completely random, not a hint of a pattern in sight. Things are chugging along. There is still a feeling in my gut that something is wrong and something is not right. So again, logs are clean, metrics are green, that one that we have. But I decide to add more timing information to each part of the application and start tracking more and more. And suddenly, once I graph those values, I see that the time to process the message completely is too long. So now I have something to dig into and something to track. So I'm digging into that part of the application. I'm adding more timers. And turns out that the database writes are slow. And a lot of time is passed before they are completed. So if you have like 2,000 workers, and each of those workers is writing in a database, do you know what that's called? Really? Come on. What? What? No, DDoS. We were basically DDoSing your database. Yeah. Welcome to my world. All right, so what do? Again, take an X to it, right? So now we're going to rework the system just a little bit. The part that is writing to the database is going to go into a separate worker, which is awesome. This allows us to let the processing workers work at full capacity and deal with the messages later. But now, because we have a separate queue for the messages that needs to be written into the database, we can actually use them. So there is no more waiting time, so that's awesome. On the other hand, the DB workers now do not need to insert per message, but we can actually batch them up. So let's say 100 messages per batch, which means it's a lot faster and we are not overtaxing the database, and it is awesome. When the transition was done, with this change and a few more, we ended up with a system that could take 200% over capacity that we needed and that we forecasted for the next 5 years, which allowed us to shut down some of the infrastructure and save about 20 grand a month, which is kind of nice. Again, one day, one of these systems stops, and we're not talking about, hey, it's slow, we're talking about dead stop. I SSH into the box. The terminal is extremely slow. Like, I press a button, and 5 seconds later, a character appears. So, okay, turns out there is no more space on the drive, right? No more space on a 100 gigabyte drive. So the usual suspects do not give me anything. I decide to look into the logs, and lo and behold, there is a log file of over 100 gigabytes. All right, sure. Oh, sorry, 80 plus gigabytes at that time. So basically, it just jumped up everything. As there is 0 bytes left, I cannot open it, I cannot cat it, I cannot do anything about it. So I decide to delete the thing, and suddenly we're back to normal. Sure, okay, fine. Desperate times. I let it loose again. I monitor it for a few days. I forget about it. Again, months passes by. The system again stops. I log in, check the logs, different log file. Again, I delete it, like move along, whatever. A couple of months pass. Again, same thing happens. Sure, fine, I'm done. I'm getting to the bottom of this. I'm going to make this app great again and get the client to pay for it, right? One huge log file, I delete that, the system is performing, but this time I decide to pick up all the rest of the log rotations and see what's going on locally. I'm trying to analyze, right? So I pick one from the worker that created the mess, I unpack it, and I break my machine. I had to abort the unpacking of the data when it grew over 50 gigabytes in size. Neat, right? So I decided, like, maybe I was wrong, I'm going to pick another one, right? 100 megabytes of a zip archive. How bad can it be? 20 goddamn 6 gigabytes unpacked. Text file. Okay, so now I have something to trace because this is abnormal. Like from 100 gigabytes to 26 gigabytes, something doesn't track. I open it, and 99.999% of the log is one line repeated over and over. Index out of bounds. Beautiful. Awesome, now I can pinpoint the problem. So it is a matter of edge cases. For the reasons that I choose to forget, the application was using shared memory and semaphores. And under certain conditions, and arrays, and under certain conditions, the index of the array would break out of bounds and it was never reset. The system was sending us nice warnings. We never cared about it, we never noticed it. And by the time we caught it, it was too late, right? Again, this part of the application didn't have unit tests, didn't have metrics in the segments. That was changed. And basically, it was about 3 lines of code to fix, and we lost about $100,000 for that episode. That was fun. For those of you who are still paying attention, the valid question would be, but why wasn't there a separate log partition, right? Well, the reason is a 10x. So we had this awesome engineer that was above us, and he was basically directing our work. He was incredibly smart, he was incredibly clever, but he was making some short-sighted decisions as he believed that we are going to be able to change it quickly when the time comes. Unfortunately, many of those decisions were not documented. So when the time came for him to leave, we were left with a lot of gaps in our knowledge. In this particular case, there was actually the EBS volume that was set for logs, but it was not set to auto-mount on reboot. Nobody knew. And this was documented exactly nowhere, so the lesson here is live and learn and document, right? So, again, new story. When working with our distributed systems, clients expect them that you can scale them up quickly. Unfortunately, sometimes that is not the case. In our case, the problem was the technical decision that files that need to be processed are stored on a local hard drive. So that worked okay for a while, but as we added more and more workers and multiple boxes, we couldn't guarantee the message reception to actually match them to a box, and it was quite fun. We had 100 gigabytes at our disposal, but still it was a shoot and miss. So, yeah. The reason why, again, local storage of files. Once you start using words like distributed, like messages and stuff like that, the word local cannot be used anymore. It was a really lovely chat with a client where I have to explain them why things are slow and what can be done with it. It was rather well. They weren't very unhappy. I managed to make these changes to S3 in about a week. We tested and deployed, things are working, but I needed to make sure that everything was working in real world. So one of the boxes actually had new changes running to see what's happening. And in the last day before deployment, I noticed that the time to process is again slow. And the reason is that the data is being downloaded to the hard drive and then passed to HTML to an image, which generates the image, then saves it as a file, and then we send it back to S3. So basically, we are trashing our hard drives, and this was taking the performance penalty. First investigation showed little promise because the version of HTML to image that we are using was not supporting streams, but turns out that the recent version was actually supporting streams, but it was not documented. Again, a few hours later, the changes were implemented. The performance was back. The penalty was this time at memory, but it is not a problem because it turns out that the process was actually twice as fast as before. Yeah, I'm going to need a sip of water before this one. This is a doozy. So one fine morning, again, new ticket that says that there is a lot of data missing from the processing information. Again, simple system, collects data from external sources, create them, right? You have workers that are distributed across several instances. Part of the time, they are simply failing without rhyme or reason. You have no idea. As we're talking with scraping, of course, like it's a markup change, right? That's the first thing that comes to mind. So I start downloading the sample data across all instances, collecting them, integrating them into test suite. The tests are passing. Everything is working. Still dropping data, still no pattern in sight. All right, time to do the things hard way. I start browsing and reproducing the steps that are required to get the data. This is a very consuming process because the pages that we need are not easily accessible. So again, a couple of hours are lost before I can see that the things are working in browser as they should. Sure, as a last-ditch effort, I copy the request from the Chrome DevTools, paste it in the terminal, it works. I run it from the application, things do not work. Like, what the hell? All right, let's see what happens when I output the last request and response. Basically, this is a two-liner output. The first is the request method, the second one is the URL. and then I get my first big break, right? When I do a post, the last request shows the get. Like, what? Remember, code has not been changed. This should not happen. All right? Time to bring out the big guns, aka Wireshark. For those of you who don't know, this is a network protocol analyzer. And then I see it, and things are making sense. So, a get, right? What's happening is I'm sending HTTP request post. The site sees it and sends me back to a 301 to HTTPS. I don't see it in the application because the redirection is enabled, and the last request is going to be a get. The reason why this is happening randomly is because the application in question is starting to roll out the new setup, and it has not reached all the servers. So awesome. So I had to enforce HTTPS. To fix this, I needed to add one S into 2 config files and be on my merry way. 18 hours have been spent on this. Beautiful. Fun stuff, right? Yeah. One fine day, an email comes. Yeah. It gets better and better. Yeah. I can do this is psychotherapy for me. This is just me letting it out. It says that Amazon has caught one of our IAM keys in the wild. Okay, and that we should take steps to fix that. All right, we need to take immediate action, rotate all of our keys, sanitize, yada, 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 yada. We do our investigation. Turns out that that key has been deprecated some 6 months before, and we have no idea how it got out, but you know, it is what it is. We send an email to Amazon. Amazon says, fine. We say, fine. Everybody's happy. We move along, right? Everybody forgets about it. Fast forward 6 months. I'm getting up in the morning, making me some coffee, sitting down in front of my machine, putting on my dashboard, and something is wrong. There are way too many counters off, like not down, but basically not getting any data. And those that are getting data are way above the acceptable thresholds, right? So what's going on? I log into the AWS console, and this is where the roller coaster starts, right? The application is leveraging spot instances. For you of those that don't know, they are dirt cheap, disposable computing power and mass, right? And we are using them heavily. There are no more spot instances running. Not only that, spot instance requests are gone. I have a problem. I need to spin up new EC2 instances to compensate for that. I can't. What is running is running. I cannot spin up a new hardware. This is going to be trouble. This is going to be a long day. I know it. And it turns out it was actually a masterclass in case engineering, right? I'm trying to contact the Amazon support. They're not giving me any response. Time passes. We are 3 out into the outage. 3 hours are gone. So I have 3 hours till the morning shift comes, because this is an Eastern Seaboard time. I need to have at least part of the data processed so they can work, right? I'm calling the CTO of the company. It is 9 o'clock in his time zone. The phone call goes to voicemail multiple times. Nobody is responding. I'm trying to contact the Amazon support with my phone number, but they don't call because it is not on file. Time passes. It is noon my time zone. It is 6 a.m. their time zone. CTO is up, sees the missed calls. He comes online. We're talking. And this is where I realized I just had a masterclass. So the email that Amazon was using was not in regular use. He basically checked it maybe twice a year. Took him about an hour to find the password, actually. That was fun. Support actually tried to contact him, but there was no one to reply. So he contacts the AWS support and clears it with them. And times pass, like we are, I think, in hour 8 of the outage, so 2 more hours have passed, and the information is now coming in about what actually happened. So remember that key from the beginning of the story, where Amazon said it was all okay, and we said fine. For some reason, it was flagged in a back audit, and Amazon decided to protect us by blocking our whole account. Yeah. and they used email they had on file. Awesome. All right, so now everything is cleared. The account will be restored in the next hour or so. I asked about the spot instance request. They're gone. As the policy of the Amazon is to shoot first and ask questions later in situations like this. Next few hours, and this is on me, I am putting back everything back because I didn't have this part automated because honestly, I never thought this was possible, right? 16 hours later, we are back in business. Can anybody guess what is the damage for 16 hours outage? Just a ballpark. What? $1 million. $1 million of revenue lost, plus the daily wages for 300 plus people that are going to get paid, but they couldn't work because we were out. Awesome. Again, few months pass. This is a system that, again, 300 people are using it, so it is a live thing. So one fine morning, Eastern Seaboard time, as people are arriving to work and things are picking up, we start getting the reports that the website is slow because this is an internal web application used for everybody. This is a back office system, and I'm seeing on dashboard that across all the systems, things are not going well. So a team member is looking into the logs. I'm looking into the database. I'm seeing a lot of failed database operations. I'm listing the processes. I'm seeing quite a few of them that are waiting, that are blocked by something else, and the new ones are coming in. And this is not a small database server. This is, at that time, R3 4X large, 16 cores and 100 plus gigabytes of RAM. Again, everything is starting to crawl. We need to do something. I'm killing all the queries in the database, trying to improve things, but new ones are coming, and I'm still bogged down playing the whack-a-mole. They're trying to, while the team is trying to determine which part of the application this is coming from, the database server is starting to go down as a Titanic. This needs to stop. We need to do something. So finally, we identified that this is coming from the warehouse-related code. Awesome. And I make a decision to kill the web server. Right? 60 seconds, go down, everybody is going to time out, and after that, we're going to see what's happened. It's an ugly solution, but desperate times. We kill it, we wait, we restart it, and suddenly everything is back to normal. Like nothing happened. Okay, they're making money, so I'm happy. I call the CTO, I ask for the on-site team to go out, and I'm telling them, you are not coming back without an explanation of what caused this, right? And they come back with like an hour or so back with a mother of a story. So, warehouse-related code. It is basically a station similar to this. There is a keyboard, there is a screen in front of it, there is a conveyor belt. On a conveyor belt, a crate will come. You have a barcode scanner, which you use to scan the barcode from the crate. It goes into the system, does its thing. There is a place where you need to place the barcode scanner when not in use. For some reason, the barcode scanner was not in its place, and it was placed somewhere here, above the keyboard. Something happened. Somebody passed, somebody bumped into the station, it really doesn't matter. The barcode scanner slid into the keyboard and landed on the F5 key, basically triggering an infinite refresh. Yeah, that's thinking. Yeah, you find it funny. At that point, it really wasn't. Yeah. If you think I'm lying, I have screenshots, just in case. Right, and because this is this is a full page application, the browser is in full screen, and the screen that they're using is using some very costly queries. We are basically killing our database server and the rest of the system, right? So that has been handled gracefully. A month or two later, again, I'm getting the notification. Oh, I have 5 minutes more. I'm getting a notification of, why is the application down? I go, no, it's not. I'm seeing it's working. And they go like, yes, it is. And I go, no, I'm sending a screenshot of the dashboard. Like, this thing is working on my end. Like, figure it out. Send the team out and, They do it, and within 15 minutes, the team comes back and they go like, yeah, it's us, it's not you. And I go like, no, you're going to tell me because you came back way too fast and you're not telling me what has happened. So now spill it. So this is a company in America, in a small city. They are growing rapidly and they are hiring people left and right. So the city decided to award this company, to do something nice for them. So what they're going to do, they're going to build a parking lot in front of the company. This is supposed to be a surprise. So the city comes up with the bulldozer, right? And with the hoe, the first dig that they do, they rip up the optic cable. Yeah, good luck preparing for that. So the next day, so for the rest of the day, in the next day, there was a person crawling through the air ducts, just setting up wireless access point and the backup system to actually handle that, right? So working with distributed systems is about as close you're going to get to working with an actual artificial living organism. Things are going to go wrong in spectacular ways where you have absolutely no control over it. And unless you're slightly crazy, you're not going to have a good time. Thank you.